Today we are discussing one more new topic in the core Java, that is the discussion about Java.lang package classes. So remember, more than half of the more than half of the core Java API exists in this Java.lang package, because in Java.lang package all wrapper classes belongs to Java.lang package, like byte short, integer long, float double, character boolean, string buffer, string builder. These are all part of Java.lang package. The next, all exception class, and almost all exception classes and supermost exception classes and majority of the exception classes exist in Java.lang package. To the exceptions, the supermost class, throwable, from throwable, error and exception. So many error subclasses, so many exception subclasses. And from exception, there is one more subclass called runtime exception. From runtime exception, some more classes are derived. So these are error subclasses. And classes which are directly extended from exception class are called as checked exception. From the exception, runtime exception class is derived. The subclass of runtime exception are called as unchecked exception. So majority of the exception classes and their subclasses are all part of Java.lang package. So exceptions we covered. Wrapper classes we covered before in the very beginning of the sessions. And last few videos back we covered string buffer, string builder. The next we discussed threads. To implement threads, two ways of implement threads. One is by extending from thread, and second one is by implementing from a runnable interface. So those thread classes are also a part of Java.lang package. Threads, exceptions. The next, string buffer, string builder, string family, all wrapper classes, including object class, system class, process class, runtime class. These are all part of Java.lang package. In this topic, we are discussing object class, system class, and object class will discuss, later on we'll discuss the system class, process and runtime. The first will cover object, then next related one class, then third system, fourth process and fifth runtime. So this is the order I am going to follow. Coming to the object class. This object class exists in Java.lang package. In Java.lang package, public class object class exists. This class acts as a supermost class to all Java classes. It acts as a superclass to all Java classes. Irrespective of whether the Java classes are user-defined classes or predefined classes. Predefined classes means nothing but the classes which are given in JDK and in other frameworks and APIs. They are predefined classes. User-defined classes are classes which we write in our application development. So this Java.lang.object class acts as a supermost class to all the classes in Java. If you want to roughly find out what type of classes we implement in Java, if you ask me, I'll just give a brief glance, which I kept at the end, at the end of the presentation. This is about the types of classes we write in Java. In Java, we'll write Java beans. Okay. We may not be knowing all these classes at this moment, but in the overall duration of learning Java, we will come across various types of classes. So we'll write Java beans or POJOs or VO, DTO, VO, BO, entity object, domain object. Almost all are similar Class which contains private variables, public set regetter methods, constructors. Such type of classes are called as Java means. The next is standalone classes which contains public static void main, standalone programs. And only in the standalone application, the standalone classes are written. So the standalone applications may be a graphical user interface applications or maybe a non-graphical user interface applications. The next, factory classes. Factory classes we use very much, especially in the abstraction example. For an abstract class or interface, we implemented 2-3 subclasses. And along with in the abstraction example, to achieve runtime polymorphism. So for one abstract class or for one interface, we wrote 2-3 subclasses. To create any one of the subclass object, we wrote factory method only. That takes which subclass object you want, that it takes as argument, the factory method. And internally, the method will return one of the subclass object. The return type of all the subclasses is maybe any abstract class or super interface. So in that abstraction example, in that runtime polymorphism example, we wrote factory class and factory method plus one client. So one abstract super class, minimum 2 subclasses, 3 plus 1 4, one factory class 5, one client program 6. So there we have written factor class, and we'll write factor classes very much in our applications. Wherever we want frequently some class objects, if you want to create it, there we'll use factor classes. Anyway, we'll discuss in the advanced most concepts. The next, validator classes. This is very, very important. Especially in application, when we take input from the user, we don't accept user input directly. We'll take the user input, we'll perform all the validations like min length, max length, not null validation, date validation, email validation, mobile validation, other mobile number validation, URL validation, credit card validation, PAN card validation, Aadhaar card validation, social security number, zip code and pin code. Like any other pattern, if you want to compare like a college roll number, we can go for regular expressions. Regular expressions or string functions are used. These two are used to do the validations batch. Validation classes. The next, business logic classes. The next, DO classes. Classes which perform insert, update, delete, select operations on database. They are called as DO classes. Thread and runtime runnable classes. Comparable classes. Comparator classes. Remote classes. Web components. Web service components. Interoperable components. SOAP and REST. Distributed components. RMA, Corba, and DJB. Web service components. Servlet, JSP, threads, action classes. Spring controller classes. JSF managed means, etc. These are various varieties of classes we'll implement in Java. These are all user-defined classes. If you ask me what are various user-defined classes we write in Java, I named few. These are the only classes we implement in Java. This is just only for the knowledge sake, what type of classes we write. The next we'll go to, fine. So we understood that java.lang.object is a supermost class to all the Java classes. Why object is the supermost class to all the Java classes? Before knowing that, we just want to have a brief look at what are various functions exist in the java.lang.object. The three most commonly overridden functions from java.lang.object into every subclass is equals, hashcode, and toString. In the last few sessions, like in encapsulation example we saw, and that equals, hashcode, toString method implementations. The next, somewhere in not exceptions, in string class also, I've shown how hashcode and equals methods are, where they are used. toString method, that I've explained in the last class. We saw these equals, hashcode, toString method implementations in many examples in the previous videos. And in the last threads topic, we too saw the wait and notify methods in method synchronization and object synchronization. Different wait method signatures and notify all methods are also there. And this wait, notify all methods are used in method and object synchronization in threads. Wait, notify, notify all methods are not overridden, they are used in the synchronization. Equals hash code to string methods are overridden in almost every class in Java, the list of classes which I have mentioned earlier. And sometimes optionally we will override, clone, finalize, and get class method we don't override, we use it. I'll write down. Equals hash code to string will override in subclasses. Clone and finalize also will override. And get class will use. Wait, notify all will use. We don't override, we'll use these methods. Get class and wait, notify methods. Clone, finalize, and equals to string hash code methods will override in every class. Why we need to override, and we'll discuss about that now. Why Java.lang.object is the rootmost class? Because what happens if we don't write object as a superclass? For example, here I wrote one class called class hello. And the class is having one method called public void say hello with string name as a parameter. Some class name with some method name. So from our previous videos knowledge, we remember one thing, we understood and we remember one thing, that whenever we compile such a class, we know by default in this class one default constructor will be generated. That is what we know. We know that one default constructor will be generated in the class. The default constructor is the constructor of the same name as class name, with same access specifier as class access specifier, and with no parameters. This is what called as a default constructor. So as we discussed, if you compile this class, one default constructor will be generated, is what we remember from the last sessions. But along with that, while compiling the class, if you write a class without any superclass, without any superclass, and without extending from any superclass, if you don't extend from any class, if a class is written without extending from any superclass, during Java compilation time, the class will automatically extend from object. The class will automatically extend from object during compilation time. Compiler will check, is this class having any superclass? No. Simply it will put extends object and then compiles this class. Plus, because this class is also not having any constructor, it will provide one default constructor. And that too, from the default constructor, a superclass constructor calling statement will be included in that constructor. So this is how Java.lang.object class becomes a superclass to all the Java classes. And if you don't write any superclass to our class, by default compiler will extend our class from superclass. If you extend from any superclass, then it's okay. Then the compiler will keep quiet. You don't extend again from object, right? This is clear how hello class is generated. One is by extending from object, and second one is superclass. One default constructor, from that calling superclass constructor. This is a defaultly generated code during compilation. And if we see another example, I'm writing one class called hi, extending from the previous class hello. Class hi extends hello. In this class also we kept some function, public void say hi. Class hi extends hello. We are extending from hello class, and we are writing a superclass to hi. If you compile, the class hi extends from hello only. The class is not extended from object, because to the hi class, hello class was mentioned as a superclass. But to the hello class, because of no superclass is mentioned, compiler by default extends the class from object. So here also no parameter constructor, one default constructor is generated. From that superclass constructor is called superclass constructor is hello class constructor. From the hello class, a superclass constructor is called object class constructor. And you implement say hi method however you want. So I'm not particular about the methods. Now coming to the main method, here I created object of hello class and created object of hi class. I created object of hello class and I created object of hi class. You tell me, this hello, this HCL was small letter hello, to which object this hello belongs to? Which object? Because we created hello class object only, its reference is hello, So this small letter hello belongs to hello class object only. So prove it. So to prove, in Java we use one operator called instance of. In Java we use one operator called instance of. With the instance of operator we can prove that the object belongs to so and so class. So here I am writing system.out.println is hello instance of hello small letter instance of hello h cap letter, and is this hello object is an instance of hello? If true, true will be printed. If not, false will be printed. So true will be printed. Then I'm asking one more question, because I just wrote only class hello. I don't know how compiler internally generates hello class. Whether is it extends from object class or not, that I don't know. But I want to check whether is really that hello class is a subclass of hello or not, object or not. So how should I check? So you repeat the statement once again. System.out.println is hello instance of object? We're asking. Because of hello class by default extend from object, this statement immediately returns true. Yes. Hello is an instance of object also, because every subclass is an instance of its own class and as well as its superclasses also. Its immediate superclass, to its superclass, to its superclass, to its superclass of the object. Here I am writing is high is an instance of high class. Yes. Is high is an instance of hello? Yes, because high extends hello. Is high instance of object? Yes. See, small letter high, it's an instance of high class. It's an instance of hello also. It is an instance of object also. Because hello, high extends from hello. Hello extends from object. All are true. Is it clear? Even if you don't write any superclass, by default, classes which are not extended from any superclass, they will be by default derived from Java.lang.object class. Now we'll get it out. Why Java.lang.object acts as a superclass? To tell that, if you write a class, how do you prove that the class belongs to Java class? Because coming to me, I know C++ more than an average, because I studied long back during my academic days. Java complete. The next C# programming I do less often, but I do Android programming. And the next I use TypeScript in Angular, and I use object-oriented JavaScript in React.js and other JavaScript frameworks. And in the PHP also I'll write classes. In Python also I'll write classes, and I can use PHP as object-oriented programming language, Python as object-oriented programming language. 8. C++, Java, C#, PHP, Python, TypeScript, object-oriented JavaScript. These many. So when I write a class, somebody asks me, prove that your class is a Java class. To prove class as a Java class, if you find out our superclass, if extends from Java.lang.object, then the class can be recognized as okay, right? It's a class belongs to Java. And for that marking sake, or for that recognition sake, we'll extend our class from supermost class object. If not object, something else. The name can be something else. But in Java, all classes should come under one root of the hierarchy, under one roof. That roof is the Java.lang.object. And second reason why Java.lang.object acts as a superclass to all the Java classes, because this object class provides some common functionalities that are required to all the classes. What are the common functionalities required to all the classes? Because Java.lang.object wants to force. So force and like there's no force as such, because those methods are not abstract, in fact. But Java.lang.object says strongly recommends that in every Java class, you override equals to string hash code. These three methods according to your class instance variables. However, your class instance variables, that is how you implement equals hash code and to string methods. Plus, as per your demand, you can also override the clone and one more is clone and finalize method. Those two methods also you can override based on the necessary. Plus, get class. If your class want to be introspected, that we'll see at the end of the presentation. If your class want to be introspected, then also we'll use that get class method. We'll get the class object and we can introspect it. And more importantly, in every class, different wait methods and notify methods are also available, because in threads, what will be synchronized? In threads are not synchronized. Remember, in threads, from the thread, our synchronized methods or our object used in multiple threads are synchronized. Threads are not synchronized. Thread synchronization doesn't mean the threads are synchronized. Thread calling methods, thread used objects are synchronized. So hence, the wait, notify all methods must be available in the classes which are having multiple methods those who want to run synchronously or simultaneously in the threads. So wait, notify all methods must be available to every Java class. That is why those methods are given in the Java.lang object but not in the thread class. Thread scheduler uses these methods, but these methods must be available in every normal Java class. So that is why we implement we use wait, notify all methods in all the Java classes because they are coming from the Java.lang object. That's all. So how I've shown all these examples in the last videos. How equals to string hash code methods are implemented in the string class. As you already know, string is a fixed length character array, and the string is internally a character representation. So equals hash code to string methods are implemented based on its character array. In the last video, I've shown how equals method is implemented, how hash code and to string methods are implemented in to string class. Based on its internal character array, those methods are implemented. How equals to string hash code methods are implemented in date class? What date class contains? Date class contains date, month, year, hours, minutes, seconds, and milliseconds. So based on those 7 variables, equals hash code to string methods are implemented. There is no standard. There's no standard implementation of the methods is standard way of implementation. But implementation varies from class to class because it depends on the methods implementations depends on its class instance variable. Similarly, if you write employee class, in employee class, equals hash code to string methods are implemented based on its class instance variables like employee ID, employee name, salary, designation, student ID, student name, roll number, that this, customer, product, item, order, and many more. Bank account, credit card number, driving license, PAN card, etc. So we can say that this is how equals hash code to string methods can be implemented, but the implementation may not be common to all the classes, right? There varies from class to class. Probably here I've shown one example. If you want to compare any two objects like string 1 and string 2, if you want to compare, use equals method. If employee 1 and employee 2 want to compare, use equals method. If date 1 and date 2 want to compare, use equals method. Now on objects, we must use equals method to do two objects of the same class comparison, but we should not use equal to equal to methods operator must be used only on comparing to two primitive variables, or we can use equal to operator on two objects also, but their addresses will be compared but not their state. So to see how the equals method, hash code to string method and other methods are implemented, I took an example of employee, class employee with employee ID, employee name, salary, and designation. 4 variables I've declared. So how to implement equals method? Public boolean equals object O. Then in the equals method, what we should check? First of all, we should convert this object into employee class type. And from that employee object, we must retrieve employee ID, employee name, salary, and designation. But before converting the object into employee type, what guarantee that in the employee class equals method comparison, employee object is passed as argument? Why not a department object is passed? And for the testing sake, why not a department object is passed as argument here? What happens if employee 1 dot equals of dpt1? Because employee 1 is also an object and dpt is also an object. Passes, if what happens, we will do. Suppose in the equals method, without checking whether this object belongs to employee or not, if you directly, typecast the object into employee, and without checking like this, if you directly typecast like this, suppose if department object is passed in, if department object is trying to be typecasted into employee type, immediately we'll get a class cast exception at that runtime. So in order to avoid class cast exception, first of all, we need to check whether this object is an instance of employee or not. If yes, then with that confirmation, you typecast object into employee. Then do the rest of the implementation. But always remember one thing, that while implementing method, the 2 standard steps you need always follow while implementing method is, to the method, whatever return type exists, with the type you declare one variable in the method, a local variable, and a return type typed one local variable must be always declared in the method, and that variable must be written as a return statement at the end of the method. These two, the moment you open method, these two you do them first. The moment you open method, whatever return type your method consists of, the type one variable you declare first as a local variable, and mention that statement as that variable as a written statement at the end of the method. When you're working with IDEs like Eclipse or NetBeans, if you write any method with a return type, and the moment you enter into the body, immediately you will get 2 errors. Immediately you will get an error. The error saying that return type is missing, return type is missing, return type is missing. At least if you write return 0 for int return type, return null for any string or any object type, if you write return null, then compiler, then ID will keep it. Otherwise, it continuously gives us error saying that the method return type is missing. But if you are typing Java program or Notepad, you don't get any such errors, right? So as a programmer, we must always make a habit of declare return type typed one local variable first, and that statement should be used in the return statement. These two you do first. Because of equals method return type is boolean, I declare a boolean flag is equal to false. Here I am checking whether this object is an instance of employee or not. If object is an instance of employee, then I am typecasting into employee object. Then I am writing here, if this dot employee is equal to, and I'm comparing the current class instance variable employee with employee which is passed employee of the object which came for here for comparison. This dot EAD is equal to even dot get EAD. So similarly, if employee should match, the next both objects employee name should match. Employee name is because of string, I'm comparing with the equals method. The next salary I'm matching, the salary is double type, so that I use equal to, and the designation string again, the strings are compared with equals method. So like that, the object which came here for the comparison, that object's state we compared with all the class and class variables of this current employee class. If all are same, then initialize flag is equal to true, return that flag at the end of the method. This is how the equals method is. The next, coming to toString method. How to implement toString method? Simple. Concatenate all class instance variables as a single string with some empty string as a separator. I'm sorry here. I forgot to change. This. I copied it from the student class. Anyway, no problem. I changed clone method, but I forgot to change here. Your written employee ID plus employee name plus salary plus designation. That we should return from the toString method. Coming to the hash code method, especially hash code method, you always implement hash code method next to toString. Because why? hash code method should return integer value for our entire object state. How to convert our entire object state into int? First, we converted object into string, right? So you call to string. So our entire object state will be converted into string. Then you call in the string class already hash code method is implemented, and just call dot hash code. The string class hash code method implementation will come. That will convert our complete employee object state into hash code value. Simple. We need not have to pay extra effort to write, a hash code method implementation on our own. Some concatenating each character with some constant value 31, something they have written in the string class. So you can use it. That is recommended one also. That is a recommended way, hash code implementation. The next, how to implement clone method. How to implement clone method. Clone is also one of the methods in Java.lang object class. Clone method we can optionally override, but not always mandatory. How to implement clone method? Suppose if anybody asks even dot clone method. Clone is common method in all the Java classes. So how to implement clone method? Suppose if even dot clone method is called, as a as the one who is writing the class, it is our wish whether when the clone method is called, whether we want to give our object as a shallow cloned object or a shallow cloned object or deep cloned object. We have to decide. And as an author of the class, we have to decide whether we want to give a shallow copy of our class or deep copy of our class once the clone method is called. So what is a shallow cloning means and what is a deep cloning means? See, shallow cloning means nothing but giving one copy of our object to others. Suppose if I write in a shallow cloning, you write return this. What does it mean? Suppose if anybody calls even.clone, they will be given one more employee object E2. But if it is shallow cloning, both employee object and employee to object both will point to same memory, because E2 is returning it's the same reference back to the client who is calling clone method. He will get E2. Though he takes the reference into E2, even E2 both are points to the same object. This is shallow cloning. In case of deep cloning, if you want to return a deep cloned object, we don't want to share our object address with other employee objects. Then you do deep cloning. How to do deep cloning? See, simply you create one more employee object in the clone method into that employee object through set ID, set name, set employee name, set salary, set designation methods. You pass our current employee object state and our employee name, our salary, our designation, our employee name, our salary, our designation. You pass into one more new employee object and return that employee object to others. So if anybody calls even.clone, they'll get one more employee object with the same state. They'll get one more employee object with the same state, initially with the same state. But on this employee 2, if any salary or designation are modified, they are not reflected in the even. In case of shallow cloning. In case of deep cloning, if somebody calls E2.set salary and write even.get salary, if you write whatever changes E2 made will be reflected in the even, because not reflection addresses, even address, E2 addresses are two different, but both are pointing to the same object. So you can modify or you can retrieve the state with any one of the objects in case of shallow cloning. So whether your objects want to be shared with others as a deep cloning or as a shallow cloning, that you have to decide. So as the author of the class. And that is about clone method. And what about finalize method? See, finalize method. Right. In Java, to create object of a class, we use one method called constructor, right? We use one constructor. We use one method called constructor. So even employee even is equal to new employee. If we use employee class constructor, employee class is for two reasons. The constructor is for two reasons. The constructor does two things. One is the constructor primary job. Generally, as a developer, we feel like in the constructor, we'll only initialize our class instance variables. But internally, again, not developer, internally the Java runtime environment will do a lot of things with the constructor. Whenever we call employee class constructor, immediately employee class superclass constructor will be called. If that superclass derives from some not organization, it's from some class. If that derives some object, from employee class, it's superclass. From that, it's supermost class. Keep on up to object class will be called. And memory calculation required for the superclass, to which subclass, to which subclass. Finally, employee class constructor will calculate my employee ID, employee name, salary, designation. 4 plus 8, 12 plus some around 50 bytes are required. And the employee class constructor calculates it for its employee ID, employee name, salary, designation 50 bytes. And its superclass requires some 10 bytes. Its superclass object class requires some 10 bytes. Like that, it will calculate and finally tells that to the new operator, tells that my employee class and my all superclasses require some 60 to 70 bytes of memory. Then one new memory will be allocated with 60 to 70 bytes of memory. Their employee class and its superclass, all the objects, instance variables memory will be allocated here. So with the help of constructor, we'll create object. Not constructor will create the object. With the help of constructor, we'll create the object. Plus, in the constructor, what we'll generally do is we'll initialize all the class instance variables, like employee is equal to 0, employee name is equal to null, salary is equal to 0.0, designation is equal to null. If any boolean variable exists, is equal to true or false, like that. So as a developer, we'll only do class instance variable initializations, but the end user, how they use constructors, with the help of constructor, the class objects are created. Fine. But there is no mechanism called destructor in Java. What is the purpose of destructor? Purpose of destructor in C++ is different. When the destructor is called, the class object is garbage collected. But in Java, no destructor concept is given, because Java is one of the important feature is automatic garbage collection. So in Java, we need not have to garbage collect any object. We need not have to destroy any object. Whenever our objects are garbage collected by garbage collector, or whenever our objects are called garbage collected by garbage collector. But we don't have any method when garbage collector is garbage collecting our object that we do not know. We do not know when garbage collector is going to garbage collect our object. And as owner of the class, we want to have a notification, an intimation. Before garbage collecting my object, garbage collector should inform something through some function call. It should inform to me, to the developer, as a developer. Because in the constructor I did initialization, somewhere in one more method, I want to uninitialize all my variables. Like I'm connected to network, I'm connected to some printer, I'm connected to database, I'm connected to some camera, I'm connected to some device. And before shutting down my application, connection with all my external device connections want to be properly disconnected before garbage collecting my object. So, do we have any function that will be called through which an intimation will be given before garbage collecting our object? So that is what finalize method is. So if you override finalize method and uninitialize all your variables, uninitialization means just assign default values to all the variables. If you uninitialize all the variables in the finalize method, that method will be called by the garbage collector. So garbage collector, one day I'll take session on the garbage collector also, how garbage collector will work. That's how finalize method overriding. So we saw equals method, toString method, hash code method, clone method, finalize method. These are the methods usually we'll override. Wait, notify all method and get. These methods are used in object synchronization and method synchronization. Get class method is used in introspection. Introspection example we'll see later on. The next step is next one is get class method. What is the purpose of get class method? On any object, if you call event.getClass, what will happen? This getClass method will return a class object. There is one class named class exists in Java API. See, remember, small letter class is a keyword to declare classes. But there is one class exists with the name called class in java.lang package. It's a predefined class. In java.lang, one predefined class is class. So on any object, if you call get class method, that will return class object. What that class object will do? So what that class object will do? What that class object will do? With that class object, if you get the class object, and for the debugging sake, for the application debugging sake, one way I can use is after getting the class object. In the class, there is one method given called get name. If you call this method, you will get the name of the class. After using object, if you want to know its class name, object dot get class method if you call, you will get class object. Class object dot get name function if you call, you will get the name of the class. And at runtime, if you get some class object and you want to know which object it is, you immediately go row dot and that object dot get class method dot get name if you call, you will get the original name of the class. You can use it. But more than that, this class object, this class named class, is used mostly in introspection. I'll end up this topic with an introspection example. What is introspection? What is introspection? How to do introspection? See here, discussion about the Java.lang object is almost completed because we saw all the method. We saw how to override all the methods. We saw wait, notify all methods we already used in threads. Get class we used here just only to debug to which class that object belongs to know that we called out get class get name method. That is all. Now our discussion is coming to another class called class in Java.lang package. So in the class there is one static method given name called for name. We use this class.forName statement very often, not very often, every time in JDBC API to load the drivers. So this class.forName method takes any class name as argument. JDBC class name, any normally you pass java.lang.string, java.lang.string, like that. You pass any class name or java.util.dit, any class name, but make sure whenever you're passing the class name, make sure to pass the fully qualified name. Just don't pass only the class name. Pass fully qualified class of any class name if you pass as argument the class.forName statement. This statement will return a class object. Then what is the purpose of this class object? So whatever we are doing with that class object is what called as introspection. What does introspection means? Introspection means it is a method, it's a mechanism, it's a way. At runtime, I'll pass one class name to you. At runtime, I'll give one class name to you. Or I'll pass one object to you. At runtime, I'll pass one class name to you or one object to you. Can you find out how many, can you find out which class it belongs to? What is its class name? From which superclass the class is derived from? What is its superclass? And what are its super interfaces? From which interface the class is derived from? The object corresponding class is derived from? Can you find out the superclass, super interfaces, the access specifier modifiers prefixed to the class, the variables exist in the class, the constructors exist in the class, the methods exist in the class, the variables, its data types, the values assigned to it, the constructors, their signature, their access specifier, method signature, number of parameters, its return type, its access specifiers, modifiers, any exceptions that are reported through method at the end or constructor if reported through any throws class with any are there any exceptions reported to constructor? Can you find out the details about any class or object at runtime? So that is what called as introspection mechanism is. Introspection is a method to retrieve the details of its class, its superclass, super interfaces, variables, constructors, methods exist in the class. At runtime, whatever class name you give, we'll create one class object like this. From the class object, we'll get the whole information. So once if class.forName, if you pass any fully qualified class name as argument, you will get a class object. What class object contains this? Class object contains get. See, do you remember next to do JDK installation and hello program, we discussed about data types and the next wrapper classes and the next control structures, conditions, loops, arrays. The next we started programming structure. In the Java programming structure, I have explained how many parts a Java program consists of. Package declaration, import statements, class declaration, variable declarations, constructor implementation, method implementation, static blocks and non-static blocks. Package, import, class, variable, constructor, method, static, non-static. 8. Tell me, in that Java programming structure, how many package declarations exist in the class? Only one. How many import statements are written? Many. How many classes are declared? Only one. How many variables are declared? Many. How many constructors are implemented? Many. How many methods are implemented? Many. How many static, non-static blocks are implemented? Many. So, to the class, only one package exists if package exists. So, there are some classes exist without package also. Like, for example, hello, class, high class, like that. So, once you get the class object in the class, there are methods exist with the name get package that will return package class object. Package name one class exists in which package this package class exists. And similarly here field constructor method. There is one package exists in the java.lang called java.lang. I forgot to mention that name here. And this class contains methods. Those methods returns the class which belongs to java.lang.reflect. Reflection API under. Reflection mechanism, reflection API. So this package, field, constructor, method, all these classes exist in that java.lang.reflect package. So get package method returns package class object. Get modifiers return int. Get name returns the name of the class. Get superclass returns single superclass object. Get interfaces returns array of classes. Get fields returns array of field class. Get constructors returns array of constructor. Get methods return array of methods. This is how once you call get package method, you will get package object. So what are the methods exist in the package class? Only one method called get name to get the package name. What methods field class is having? Get name, get type, get modifier. Field name and variable, class instance variable. Get name means that variable name will be written. Get type means its data type will be written. Get modifiers means it's all access passwords and modifiers are written. The next get the constructors and the constructors get name, constructor name will be written. Get modifiers will be written. To construct only access passwords exist but not modifiers. Get parameter types. Parameter names may not be written but parameter types will be written and class array in the constructor. Next come to the method get name. Method name will be written. Get written type. If not written type, at least void will be written. Void is also a class. Get written type. Get modifiers. All access and modifiers that are specified to the method. Get parameter types. Parameters exist in the method. Get exception types. Exception mentioned at the end of the method. Actually, this get exception types method exists in the constructor also, because to the constructor also some exceptions are reported. File input same class constructor reports file not found exception, like that. So these are the methods of package class, field method and constructor classes. Here is one example given. Public class, and I think I have given two examples on reflection. Public class reflection demo, public static void main, string racks throws exception, class dot for name or racks of 0 as a argument. Racks of 0 means while running this program Java reflection demo, you pass java.lang.string or you pass java.util.date or you pass java.lang.thread, or otherwise you pass any of your user defined class, employee, student. You can check with various varieties of classes, with predefined classes or with user defined classes. You pass any class, but make sure you pass only the fully qualified name. And if class is in the package, you write class with the package prefix. If there is no package, something like a class kind like employee or student or something, then you can directly pass the class name. If you pass any class's argument in class dot for name, the class object will be returned. Here we are calling c.getName. That returns the class original name. C.new instance. If you load any class name with the c.new instance method, we can create object of the class. If you pass any class name at runtime into this program, This program can create object of the class also at runtime. Good. That C dot get superclass dot get name. Its superclass can be retrieved. C dot that class object dot get superclass dot get name. C dot get superclass dot get name. What is the superclass of string? To the string superclass is object. What is superclass of integer? Integer superclass is number. Number superclass is object. What is superclass of thread? Thread superclass is object. Super interface is runnable. Like that. Superclass means only one superclass. Its immediate superclass name will be written. The next C dot get modifiers. If any access specifiers and modifiers exist, that list will be written here. Get modifiers. C dot get interfaces. A class contains only one superclass, but a class can contain any number of super interfaces. Get interfaces. Get interfaces. Get super interfaces. Get interfaces. Okay, right. Get interfaces method. It's an executed example. C dot get interfaces. All the super interfaces. Interfaces are also classes. Interfaces are also classes. They're pure abstract classes. So class array will be written, not interface array. Class array will be written. C1.length, we found the length. We iterated loop. From that array, each class object is retrieved and its name was printed. Now, suppose if you write get interfaces method for a java.lang.string class. String class extends object, implements, comparable, serializable, char sequence. And the string class is having 3 super interfaces. Serializable, comparable, and char sequence. So in case of java.lang.string, the length will be 3, all the super interface names will be printed here. Get fields method, returns field array. Length I found. Iterated one for loop. From the array, each field object dot get name if you call, you will get the field name and a variable name. That field object dot get type, its data type will be written. Int or long float, double string, character, boolean, employee, array, different. Modifiers, field object dot get modifiers. The method access specifiers and modifiers will be written. The next get constructors, constructor array will be written. Array length we found. For loop one for loop we are iterating here. Constructor dot get name. Constructor dot get modifiers. Constructor dot get parameters for this will go. Constructor object dot get parameter types. All the parameter types are written as a class array of object. That all the parameters will be displayed here. Similarly, get methods. Methods array will come. Length you found. For loop you iterate. Each method name, method modifiers, method return type. Method return type returns class object dot get name means its original class name will be printed. Get parameter types, method parameter types, class array key. Before we iterated for loop, each parameter name we retrieved. Parameter name we retrieved. Parameter name we retrieved. Parameter name we retrieved. Parameter type also we can retrieve. Parameter type also we can retrieve. So this is how once a class loaded at runtime into class.for name, using that class object, we can fetch the whole class information. So fetching class information in Java program is called as introspection. Here is one more example. The difference between previous example and this introspection example is here after getting array, every time we are finding the length and iterating for loop in traditional way. Here the example is written with for each loop, enhanced for loop. Same example. Same example. Get modifiers, get super interfaces, get fields, get constructors, get methods. See that everything is same. So here ends the session on one part of java.lang package. And the next topic we'll continue the same java.lang package classes. We'll discuss about the remaining classes, what they are. One is process, runtime class or system class. System.out.println, system.in.read, system.error.println, system.get properties, system.set environment, system.set out. Here is system class is also very interesting. That will take one more session. In that session, in the next topic, we will cover system class, process, and runtime classes. With that, this java.lang package classes topic will be completed. Here we are ending up our session. Thank you.
Like, share, and subscribe. Hit the bell icon for more updates.